Use the Pythagorean theorem to find x and y. Here's the x, here's the y. Notice this is a cube by the markings. All the edges are going to be 1s on the outside, so this is a cube. Here's a right triangle. The x and the y are sides of a right triangle. But we can't use the Pythagorean theorem just now, because to use the Pythagorean theorem, two things should already be in place. It has to be a right triangle, which it is, but two sides have to be already given. And the only side we know is this one, which is going to be a 1. But we're missing two sides, so we cannot use the Pythagorean theorem just now. So what we're going to do is, we're going to look for another right triangle. We could use this one here, which has more information. And then we'll find out what this number is, and that's also a part of the right triangle that has the y. So we're going to draw a right triangle here, find this side, and then this side will be part of the other right triangle side, and we could find the y. Once we find the y, then we'll use this right triangle to find the x. So we're going to pass the information from one right triangle to the other. So let's start off with the first one. We could find this one, since we have two sides and it's a right triangle. We can apply the Pythagorean theorem. Remember, the side opposite the 90 will always be the c. So that's the side we're looking for this time. That's the c. We'll call it z instead of question mark. Take your pick, use a symbol. So we're going to go ahead and choose z for the unknown here. Run it through the Pythagorean theorem. Notice 1 and 1 are a and b. Here they are. Simplify. Take the square root of both sides. That cancels this power of 2. And now we know that z, the unknown, is square root of 2. So this length is square root of 2, which is this one. Now that we know this length is square root of 2, we draw another right triangle that involves the y. By now we know this side and this side, so we could figure out this side, which is this y. And then later on the x. So here's the square root of 2 we found. Now we let this triangle use it. Notice it's a right triangle. Two sides are given. One's missing, so we could use the Pythagorean theorem. This time the y is acting like the c. Remember, the c is always opposite the 90 in the Pythagorean theorem. So it takes the place of the c. Here's the y. 1 and square root of 2 are going to be the a and the b. Simplify. Run through your formula. Keep simplifying. And we have y equaling square root of 3. So this y is square root of 3. Now we're going to let this y be the side of another triangle, another right triangle. Notice this is the y we found. Now we're going to move it to another right triangle, which involves the x, which is the last variable we're looking for. So here's a right triangle. Two sides are given. Notice the one opposite the 90 is always going to act like the c. So here's the c. And the other ones are the two legs of the right triangle. So simplify. Square root of 3 squared, that's 3. X squared, 1 squared is 1. Isolate the x, so we start moving things away from the x, so we move the 1 over. So we get this, x squared equals 2. Now take the square root of both sides, so we could cancel the power of 2. And that leaves the x all by itself. So now we know that x also, x equals square root of 2.